All right, so I think I sorted out what the problem was. There were just lots of things open. All right, a 60 kilogram student. Let's change my pen color. Yeah, green looks fun. 60 kilogram. Yeah, all right, change approved. We're now calling it a coologram because nothing's cooler than physics. Apart from absolute zero minus 273 degrees Celsius, or 0 Kelvin. That's cooler than physics because it's cooler than everything. A 60 kilogram student weighs 600 newtons. He does a bungee jump, brave person. And it says here that the bungee jump was 50 meters of height, 50 meters of a change of distance. The bungee cord becomes straight and starts to stretch when he has fallen 50 meters. Calculate the change in gravitational potential energy as the student falls 50 meters. So it's asking me for EP, which will be measured in joules. I don't know how many there will be yet, though. The mass is 60 kilograms. Gravitational field strength on Earth is 10 newtons per kilogram, unless they tell you otherwise. And the height was equal to 50 meters. So EP is equal to mass times gravity times change in height. EP is equal to 60 times 10 times 50. And I'll put that into my calculator. I'll drop my calculator on the ground first because that's the cleverest thing to do, giving me a gravitational potential energy of 30,000 joules. And this is suddenly swinging to a battery charger. So it's obviously a different question, but that's absolutely, all going wrong. Absolutely fine. The battery charger supplies a steady current of 2.5 amps. Calculate the charge. It's asking me for the quantity of charge in coulombs. That's going through in 8 minutes. Oh, the sneaky little hobbits. Look at that. They think we're going to be fooled by minutes, but we're not, because it's not. Coulombs are the amount of charge passing by a particular point per second. So let's have a little look. 8 times 60 is equal to 480 seconds. This being a 2-mark question, if you had used 8, you would have only gotten 1 mark, but we are not going to let that happen to us, for we are bigger and better and stronger than everybody else. Well, you lot are bigger and better and stronger than everybody else. I'm just fairly decent at maths. 2.5 times 480, not 81, silly little finger. Charge 1,200 coulombs. Cyclist travels down a slope. Well, hopefully he's got working brakes. That will be able to apply a force necessary to stop the momentum of him traveling down the hill. And it's broken again. Oh, no, now it's not. The top of the slope is 20 meters vertically above the slope. Height is equal to 20 meters. The cyclist has a mass of 75 kilograms. 75 kilograms. Calculate the change in gravitational potential of the cyclist. We're looking for EP, or potential energy. And G is 10 newtons per kilogram. They were nice and they gave it to us this time. EP is equal to M times G times change in height. EP is therefore equal to 75 times 10 times 20. Pop that into my calculator, times 10 times 20. The answer is 1,500 joules. And I don't have to do anything with that because it is just wanting it in the base units. A skier going down a hill, a little bit more exciting than cycling down a hill, sure, descends to a vertical height of 200 meters. The skier's mass is 65 kilograms. I wonder what they're going to ask us to do. Calculate the change in gravitational field strength. Gravitational potential energy, pardon me, I don't know how many joules. Take the gravitational field strength to be 10 newtons per kilogram. EP is equal to mass times gravity times height. EP is therefore equal to 65 times 10 times 200. Pop that into my calculator. Times 10 times 200 is equal to 130,000 joules. 65 times 10 times 200, absolutely all is looking well. At the bottom of the slope, her speed was, velocity is equal to 36 meters per second. Calculate her kinetic energy at the bottom of the slope. I don't know how many joules this is going to be, but I do know that her mass is 65 kilograms, because I know the equation for kinetic energy is equal to a half times mass times velocity squared. So I get the mass from up there, the other question. It says there the mass is 65. This is part 2 of the same question, so I can use these units unless something changes. EK is equal to a half times 65 times 36 squared. 0.5 times 65 times 36 squared is equal to 42120. 42,120 joules. Now, have I done something silly there? 0.5 times 65 times 36 squared. Bottom of the slope, calculating net energy at the bottom of the slope. Nope, that seems to be the answer. Happy with that. Don't have to do anything with the equations because there were no prefixes. A javelin has a mass of 0.8 kilograms. In one throw, the javelin left the athletes at a velocity of 25 meters per second. Calculate the kinetic energy. It's asking me for EK. I don't know how many joules. I will write down that EK is equal to 1/2 times the mass times the velocity squared. I'm going to put EK is equal to 1/2 times 0.8 times 25 squared. 25 squared, 625 times 0.8 times 0.5 gives me 250. And the unit of energy is the joule. Not, of course, the jewel like you wear in a necklace or a ring or a bracelet or a crown or a locket or whatevs. Whatevs is what cool people say instead of whatever. I just got an email. But the joule is in Joule, unit of energy, one that comes up a lot. State the amount of work done by the athlete on the javelin to get it to a velocity of 25 meters per second. Well, work done is the same thing as energy transfers. Energy transferred. So if the amount of kinetic energy that my object has is 250 joules, my object has been given 250 joules of kinetic energy. Then the amount of energy that was required, at the very least, and it'll actually be a little bit more, but not for the sake of this question, of chemical energy in the arm required to transfer that by forces will be the same thing. If I'm going to give it 250 joules of kinetic energy, then the work done is the 250 joules. So I don't have to do any maths, just that. I'm going to pop my unit in, because if you don't put the unit in, then you'll be sad. The students produce a different wave. It's a different question, so don't worry if it doesn't make very much sense. It has a frequency of 1.7 hertz and a wavelength, sheepdaddy, of 8.0 centimeters. Tricky little foxes. You're not going to get us confused because we're going to divide that by 100 and we're going to get it to be 0.08 meters because we want them all to be in base units. And the velocity is, I don't know how many meters per second. V is equal to F times lambda, sheepdaddy. V is equal to 1.7 times 0.08. 1.7 times 0.08 equals, that's a nice one, 0.136. Velocity is equal to 0.136 meters per second. Just double check my numbers. 1.7 hertz, 8 centimeters divided by 100, 0.08. Yep, looks to be like it's going well. A van accelerates from a velocity of 2 meters. So an initial velocity, u, 2 meters per second, to a final velocity of v of 20 meters per second in 12 seconds. The time taken for that was 12 seconds. Calculate the acceleration of the van. Acceleration is equal to, I don't know, meters per second squared. And a reminder that that does not mean that I need to square the number in front of it. Rather the opposite. I need to not square the opposite number in front of it. A is equal to V minus U divided by T, giving me A is equal to 20 minus 2 divided by 12. I shall do that in my A over B, so I shall do A over B, 20 minus 2, and then I shall press down, divided by 12 is equal to, whoopsie, 1.5. 1.5 meters per second squared. The current in resistor X is 0.41 amps. The voltage across resistor X is 2.1 volts. Show that the resistance of resistor X must be about 50 ohms. Well, I mean, you'd be tempted, wouldn't you, to just do this? But we can't. So instead, we're going to have to use our equation. V is equal to Y times R. I'm going to rearrange that equation. R is equal to V divided by I. R is equal to 2.1 divided by 0.041. 2.1 divided by 0.041, giving me an answer of 51.219. Resistance is equal to 51.219. I'm going to do 22 ohms because we want it to be about 50 ohms, and that's about 50 ohms. Calculate the power in resistor X. Power, and I don't know how many watts. When the voltage across X is 2.1 volts, 2.1 volts, and the current in the resistor is 0.041 amps. P is equal to I times V. P is equal to 0.041 times 2.1 equals, oh, sorry, I jumped ahead there, didn't I? 0.041 times 2.1. P is equal to 0.08861. And it gave it to me in 3 decimal places, so I'll give it back to them in 3 decimal places. I'll write that down as well, just to be sure. I'll write in my space provided 0.0886. Calculate the overall resistance of the 22 ohm resistor and resistor X. So where are we going to find this then? Calculate the power current resistor X, so that resistance resistor X, right? No real way of doing this because I don't have a circuit diagram. But what I am going to do is I'm going to assume that these are in series. And if it's not right, what's in the exam, then we'll do it well. So I'm going to imagine that I've got a resistor 1 and a resistor 2. I'm going to call this resistor 22 ohm resistor. I'm going to call this one resistor X. Now we've worked out that resistor X is 51.22. And remember, our total is equal to R1 plus R2 dot dot dot. So how many resistors you have in series, add them together, and that's the total resistance. So our total will equal to R1, which is 22, plus 51.22, giving me an overall resistance of 73.22 ohms. The current in the circuit is 0. They love that number, don't they? 0.041 amps, like we've seen it before. Change the picture. Boring. 3.00 volts is the voltage across the battery. Calculate the energy transferred in I don't know how many joules in 2 minutes. Ha! Look at that, sneaky hobbits. No, not today. Times 60 is equal to 120 seconds. E is equal to V times I times T. E is equal to V times I times T. E is therefore equal to 3 times 0.041 times 120. 3 times 0.041 times 120, because we is not going to be fooled in it. 14.76. Sorry, 14.76. Let me just double check that. 0.0413 volts, 2 minutes, easier to V times I times T. V times I times T. Yep, seems fine by me. Energy represents the energy transfer in 1 second in the generator. Nice generator. Energy supplied 1400 kilojoules. Ha ha ha. Look at that. Look at that. Look at that little kg. They think we're going to be confused. If you ever get confused with kg or mg or capital MG or anything like that, I want you to think of 1 kilometer as equaling 1,000 meters. Now, how do I turn 1 into 1,000? I multiply the 1 by 1,000. How do I turn the 1,000 into 1? I divide the 1,000 by 1,000. So how do I go from kilometers into meters? I multiply by 1,000 to go from kilometers to meters, and I divide by 1,000 to go from meters to kilometers. And I do the same thing for kilojoules. So 1 kilojoule is equal to 1,000 joules. How do I go from 1 to 1,000? I times by 1,000. Calculate the amount of energy wasted in 1 second in the generator. The total energy, which is yon, will equal the waste energy, which is the one that comes down, just like your own waste into the toilet, plus the useful energy, which is 1,300 kilojoules. So I shall do 1,400, 1,400,000 is equal to the waste plus 1,300,000. And I shall do, I'll do 1, 2, 3, 140. 1,000, 1,400, yeah, okay, 1.4 million, 1.4 million, and I shall take away my 1,3 million, giving me a paltry, a tiny 100,000 joules, and there's my answer. Now, if you put down 100 joules, you probably would have gotten some marks, but you won't get them all. Calculate the efficiency of the generator. Efficiency is equal to useful divided by total. So, efficiency is useful. Well, pardon me, I've jumped my gun here as well. Sorry, I was trying to drink quietly. A bottle of water here. I'm speaking a lot. Oh, okay, it's not working. Oh, well. Oh, and now it's frozen again. Okay, folks, just pretend everything's okay. Nobody panic. It's okay, I've got this under control. Efficiency is a number. It can either be a percentage or it can be a decimal point. Over here, it's not asking me for anything, so I can do whatever I want. Useful is equal to 1,300,000 joules. And the total amount of energy is equal to 1,400,000 joules. Giving me my equation to be efficiency is useful divided by total. Efficiency is equal to 1.3 million. Divided by 1,400,000. And divided by 0.92 8, and I'm going to give that as 0.93. Now, most of you will have spotted that we didn't actually need to do it as 1,300,000, 1,400,000, because it is just a ratio. But still, I thought I'd do it because it was fun. Voltage is 230 volts. The current in the kettle is 12 amps. Calculate the power in the kettle. E is equal to Y times V. The power is equal to 12 times 230. I shall pop that into my calculator, giving me an answer of 2,760 watts, which is approximately the amount of watts you get when you're trying to teach younger people about maths. Younger people like yourself. Just divide it by 3. What? Just divide it by 3. What? You know, put it over 3. What? That many watts. Computer, thank you. The graph shows how the velocity of a small car changes with time. Not nice to call it small, maybe it just hasn't had time to grow yet. Use the graph to estimate the velocity of the car at 3 seconds. Simple, pimple. Look at my time on the x-axis, and look at my velocity on the y-axis. This is 0, 1, 2, 3, 4, 5 seconds. I'm going to draw up to 3, pardon me, because it's asking me to find the velocity of the car at 3 seconds. And I'm going to go across, and I'm going to say it's about 10 meters per second. Calculate the acceleration of the car when it is speeding up. Well, acceleration is the change in velocity over time. So we're going to look for the end velocity, which is up here, and that is 20 meters per second. V is equal to 20 meters per second. U is equal to the start velocity, which is 0 meters per second. Now, I will say, how do I know this is the part where it's wanting me to talk about the acceleration of the car when it's speeding up? Because in a velocity time graph, when you have a straight line that is increasing its gradient, then a straight line, a sloping line that's sloping upwards, it is acceleration. This is constant velocity, and this is deceleration. Acceleration, which I'm just going to abbreviate to acceleration, and then steady speed. The time taken for that change, it goes from 0 to 5 seconds. So that is 5 seconds take away 0 seconds, meaning my time was 5 seconds, and my acceleration is equal to, I do not know how many meters per second squared, but I shall know soon. A is equal to 20 take away 0 divided by 5. Pardon me, again, I jumped the gun. Why did I jump the gun? A is equal to V minus U divided by T. A is equal to 20 take away 0 divided by 5. Honestly, because I was doing it in my head, 4 meters per second squared, just so I could see if the answer was correct. 20 divided by 5 is equal to 4. Lovely. A car is traveling along a level road. When the driver applies the brakes to stop it, the work done to stop the car is 510,000 joules. The car is a mass of 1,400 kilograms. State the value of kinetic energy for the car when the brakes are first applied. So EK is equal to, I do not know how many joules. Now, to state the value, not to calculate the value. Right. So if I have a certain amount of kinetic energy and then I do work to stop it, then the amount of work done to stop my car will equal the amount of kinetic energy that my car had at the start. So the amount of kinetic energy in the car, I will transfer through forces in my brakes to a thermal energy store in the environment that will also be in the car, but mostly the brakes and the air around the car. And whatever amount of energy this is, so 510,000 joules, will be the same as the energy here, 510,000 joules. So I don't have to calculate anything. I'm just going to do 510,000 joules. Calculate the velocity of the car when the brakes were first applied. Now, I will need to do that for this one. Oh, this is a nice one. We have not seen this one so far, have we? Right. The EK is equal to 510,000 joules. The mass of the car is 1,400 kilograms. And I'm going to have to make my writing a little bit tidier here. V is equal, I do not know how many meters per second. So EK is equal to 1/2 times mass times V squared. Now you can either rearrange and substitute or substitute and then rearrange. I really don't mind. However, I like to rearrange first because then I can put everything into my calculator. 1/2 times mass is equal to V squared. Now, this squared, I have to get rid of that. And the way I get rid of that is by square rooting the entire left side. So I'm going to put my number in now. 510,000 joules Oh, if you want to see a video on how to rearrange, there's one up on my YouTube channel, and it just takes you through the whole process so you're no longer scared of it. 1.5 times 1,400. Let me check my numbers. There's nothing extra going on there. Kilograms, joules, everything I want. So I'm just going to pop this into my calculator. I've done the square root sign. I've pressed AB 510000, and then I'm pressing down 0.5 times 1,400. And the reason why I like using my AB sign is because there's absolutely no way that I can get this wrong due to bid mass, 26.992. I'm going to range that up to 27 meters per second. The brakes applied an average force F is equal to 15,000 newtons. Calculate the distance that it takes in meters for the brakes to stop the car. Now remember, if I want to find D, then I'm going to have to use my equation, E is equal to F times D, or maybe something else they might give you. But I already have that. So I've got my 15,000 newtons, and I've got the amount of energy up here is 510,000 joules. So I have the energy that's required to do this amount of work that will be done. And I just have to put it into my equation. E is equal to F times D. And then I'm trying to find D, which will equal to E divided by F. So I shall do my energy, 510,000, divided by my force, which is 15,000, giving me a nice round answer of 34 meters. The lamp is designed to be used in a car with a 12-volt battery. V is equal to 12 volts. When it is connected to the 12-volt battery, there is a current of 800 milliamps. Ah, look at that, you sneakies. You're not going to beat us, because in 1 amp, that is the same as 1,000 milliamps. But we're aware of your little tricks, and you're not going to get us, you sad, decrepit people. Divide by 1,000 to turn 1,000 into 1. Divide by 1,000 to turn milliamps into amps. So I shall do just that. Thought you were so clever, didn't you? Calculate the power of the lamp. Power is equal to I don't know how many watts. P is equal to I times V. The power is equal to 0.8 times 12. Much nicer than 800. 0.8 times 12, giving me a nice happy number of 9.6 watts. Just going to sit here for a second and draw a smiley face next to that so that the examiners know that I won and they lost. Oh, I won and they lost, even though my... Oh, come on now. No, just... Thank you. Thank you. Okay. I spotted something there that I'm going to try, just because talking to oneself gets really tiring. And it's broken again. Okay, let's just wait a second. I can tell you a joke I heard. No, okay, you don't have to. I'm going to use a multicolored pen now. Oh, it's going to be exciting. A motorcyclist is climbing a hill at a constant speed of 13... Oh, it's not very exciting at all. Oh, well. Speed is equal to 13 meters per second. Oh, my golly, it changes. Calculate the time it takes. Huh? T is equal to... I don't know how many seconds. Oh. Calculate the time it takes for the motorcyclist to travel a distance of 29 meters. This is so much fun. Distance is equal to speed multiplied by time. I am trying to find the time. So I'm going to do distance divided by speed is equal to a certain amount of time. 29 divided by 13 is equal to that certain amount of time. And it's not really enjoying it though. So I'm just going to have to not do that anymore. But after this one, I'm going to write 2.23 seconds. It's very precise. You could, if you want to, round that up to 2. Wow, that's so exciting. But I'm going to go back to black because it was lagging a little bit. A relief organization drops food parcels by parachute from a helicopter. The helicopter is hovering at a constant height above the ground. Good thing it's dropping the parcel and not itself. The parcel falls for a few seconds before the parachute starts to open. Calculate the velocity of the food particle after falling for 1.2 seconds. Time 1.2 seconds. Ignore any air resistance acting on the ground. Acceleration due to gravity is equal to 10 meters per second squared. So this is my end velocity. I'm going to have to use my equation here, V and U. So U is equal to I don't know how many meters per second, and V is the end velocity. That is the one that we are looking for. Calculate velocity after falling for 2 seconds. U is a start velocity, which is 0 meters per second. A is equal to V minus U divided by T. It is accelerating at 10 meters per second squared. And what I'm going to do is I'm actually going to substitute first for this one, though, because it'll make it a little bit easier for you to see what's going on. A is equal to 10 meters per second squared. V is equal to the end velocity, which we don't know. Take away the start velocity, which is 0, divided by the time taken, which is 1.2 seconds. Now, what I'm going to do is multiply across by 1.2, giving me 10 times 1.2. Of course, it's 12. 12 is equal to V minus 0. And that means that 12 meters per second is the velocity. Doubling check that, it's got seconds, got meters per second squared. It was hovering at a constant height above the ground. It drops a food parcel, so yeah, it doesn't matter because the start velocity was U. Here's your helicopter sitting up here. Do you know what? That's a fairly creditable helicopter. If the parcel is here before it is dropped, its velocity, U, will be 0 meters per second. Its acceleration will always be constant. And the time that's taken was given for us, so that question is correct. That was a fun one as well, really, wasn't it? That's the kind of maths question you invite around for a cup of tea. LED lamp is a power rating of 3 watts. What, if you would like to do it in a elongated form. The voltage across the lamp is 12 volts. Calculate the current in the lamp. Now we're getting into the more interesting ones. Power is equal to current multiplied by voltage. I'll rearrange this equation. I is to be the subject, so I shall divide across by V. P divided by V is equal to I. I'll put my numbers in. 3 divided by 12 is equal to I. I'm going to put this into my calculator, even though we all know it is 0.25, just to double check it. Current in the lamp, 0.25 amps. And there's nothing scary, no extra units. My units are asking it for an amps and not milliamps, so I'm happy to carry on. Student uses this circuit to investigate how the current in a filament lamp varies with the potential difference across the lamp. So I've got 12 volts there. I've got a lamp, an accelerator, and a variable resistor. And the variable resistor is in the halfway position. The ammeter reads 0.37 amps, and the voltmeter reads 4 volts. Now, where is the voltmeter? That does not appear to be a voltmeter. Okay, so I think what question one might have been was to add it must be show that resistance in the filament lamp is about 11 ohms. So it's going to ask for, right, I think part one would have been putting a voltmeter on that so that we would have a reading for this of 4.0 volts. So that would have been at the top of the question. But the current reads 0.37 amps, and that's taken by my ammeter, so I can use that. That's not going to be affected by the voltmeter. I'm going to say that the voltage is 4.0 volts, and I'm going to find out what my resistance is, but it should be around about 11 ohms. V is equal to I times R, my base equation, Ohm's law. R is equal to 4 divided by 0.37, because I rearranged it. V wasn't I have to make R the subject, divide across by I. R is equal to, I skipped a step there, sorry. I was just trying to, again, make sure that I was doing it right for you in my head, and I ended up doing wrong for you in actuality. 4 divided by 0.37. R is therefore equal to, hope this is correct, is divided by 0.37, 10.81. Well, I would call that around 10.81. Oh, I'm going to leave that as is. Ohms. Resistance is equal to 10.81 ohms, 10.81 ohms, and that is around about 11. Some students carry out investigations with an electric motor. The student uses the electric motor to lift a weight, so there's going to be some kind of a power thing going on here. The current in the motor is 0.5 amps. I is equal to 0.5 amps. The potential difference across the motor is 6 volts. Voltage equals 6 volts. Calculate the input power of the motor. Now, it doesn't matter about the input power or the output power, the power preserved or the power given or whatever, because we're just looking at the power, and the only equation we have for that with current and voltage is P is equal to I times V. So it doesn't matter what kind of power it is. I'm going to write my equation. P is equal to Y multiplied by V. I'm going to say that P is equal to 0.5 times 6. I'm going to say that P, and I'm going to check this on my calculator because I don't trust myself, because I've been speaking now for 58 minutes, and it's getting difficulter and difficulter. Now, of course, I should have said more and more difficult. Input power is equal to 3 watts. What? The car is traveling along a level road. The car now accelerates in a straight line. Acceleration is equal to, I don't know how many meters per second squared, but it's been mentioned. Its average acceleration is 12 meters per second squared. I counted my chickens before they hatched, but at least I was counting them. No, bad pen. That's the freeze pen. No, not the rainbow pen. Okay, again, just sit there and chill out. Acceleration is 12 meters per second squared. Calculate the increase of the car's velocity in 4 seconds. All right, time is equal to 4.0 seconds. I'm assuming now acceleration is okay. Doesn't give me a start speed, so I'm going to assume that the start speed was 0 meters per second, because again, something will have been cut off from this question. And it's asking me to find the final velocity of the car in meters per second. A is equal to V minus U divided by T. Again, I will recommend that we do 12 is equal to, I don't know, minus 0 divided by 4. And I can multiply across by 4 to give me 48 is equal to V minus 0. And then my answer will be 48 meters per second. Sorry, that took me a little bit of time to think about that. It was a bit like the one that stopped me from my last video. I had to go, to be honest, I had to go and ask Mr. Patrick what I was missing. And it just turns out we're missing some information. But I just wanted to check to make sure. A box with a mass of 0.8 kilograms is lifted from the floor and placed on a shelf. The shelf is 1.8 meters above the floor. So that will be equal to my height, and this will be equal to my mass. I shall gather those. Mass is equal to 0.8 kilograms. And my height is equal to 1.8 meters. The box has gained gravitational potential energy. You betcha it has, because it has been risen above the ground. Calculate the gain in gravitational potential energy. GPE, which I just said there, gravitational field strength, is equal to 10 newtons per kilogram. If you are watching this video and you've watched it thus far, please come up to me and say the code word chicken. Rabbit, red nose, plonker. Say that to me and you shall receive 10 achievement points. Here's your equation. EP is equal to m times g times delta h. EP is equal to 0.8 times 10 times 1.8. And as I put this into the calculator, I'm going to sadly think about the waste of time this is, because I don't know if anyone's going to watch it. If they don't, I shall make a separate video of me crying. And I've got my mass, 0.8 kilograms. It's all the right units. It's all the height, newtons per kilogram. We're happy with all of that. I get my answer is 14.4 joules. The box falls off the shelf. Oh no! State the kinetic energy of the box just before it hits the floor. Well, if it has a gravitational potential energy store, and that potential energy store is transferred through the force known as gravity, and if I started off with 14.4 joules up here, then I must have 14.4 joules here, assuming no waste of kinetic energy. So my answer is 14.4. Just before the box hits the floor, it has a momentum of 4.8 kilograms per meters per second. This is only for higher, okay? Higher tier only. Nobody worry about this if you're doing foundation tier. Calculate the velocity of the box just before you hit the ground. I'll double check that with Mr. Patrick, but I'm sure that momentum is just for higher tier. And the mass of the box has already been given to us. It is 0.8 kilograms. The equation for momentum, momentum equals mass times velocity. I shall rearrange my equation, divide across by m, p over m is equal to v. I shall do 4.8 divided by 0.8, giving me my answer. 4.8 divided by 0.8, 0.8, yes, there we go. The velocity is 6 meters per second. Yes, keep going. Come on, we can do it. Yes, yes, yes. The average speed of a P wave in the mantle is 12 kilometers per second. Speed is equal to 12 km per s. But spotting that kilometer, I'm going to multiply that by 1,000, and I'm going to give that as 12,000 meters. The P wave travels vertically down from the surface in reflection of the core mantle boundary back to the surface. It travels a total distance of 5,800 kilometers. And again, I'm going to write, I could do that as 5 million. Do you know, I'm just going to leave it nice and simple. I'll convert them both in. Now, just pause for a second. Don't physically pause because anyone hear the explanation. But because this is kilometers per second and that's kilometers and it's asking me for seconds, you could just leave it as meters, as kilometers. But we're not going to do that. We're going to do it this way. Calculate the total time. The time is, I don't know how many seconds. But I do know that the distance is equal to speed multiplied by time. I'm going to divide across by s to get d divided by s is equal to t. And the distance that it traveled is 5,800,000 divided by 12,000. 5, and then divide that by that equals 400. Golly, that's fast. The time it took was 483.3 seconds, and I can leave it as it is because it's not asking for minutes. If it did want minutes, I would divide by 60, but it doesn't, so I won't. Let me just double check that. Million Christ, 12 kilometers, 5,800 kilometers. If I did 5,800 divided by 12, distance divided by speed, the distance of that divided by the speed. Yeah, okay. Some students investigate the electrical resistance of different components using this circuit. What circuit? What circuit? We don't have the circuit. One of the components being investigated is a 12 ohm resistor. When it is in the circuit, the ammeter reading is equal to 0.5 amps. Calculate the voltmeter reading. What is the voltage? V is equal to I times R. V is equal to 0.5 times 12. That means that the voltage is equal to 6 volts. Just need to double check that though, because I often make silly mistakes. But I'm not silly today, I'm clever. A man monitors how much money he spends on electricity. It's a very good thing to do because electricity is expensive and bad for the environment. He uses a device which calculates the cost of electricity used. He connects his 2.9 kilowatt that I'm going to change into, you bet it, 2,900 watts to a 230 volts main supply, 230 V. Calculate the current in the kettle element. I equals I don't know how many amps. P is equal to I times V. Piv, the pet cat. Rearrange this. I want to make I the subject of the equation, so I should divide across by V. P divided by V is equal to I. P, 2,900 divided by the voltage, which is 230, will give me my answer. I'm just going to write down P is equal to, just for form's sake, 2,900 divided by 230 is equal to 12.608. 12.608. I'm going to do that to 12.61. Okay, 12.609. It should have been in reality. I just got lazy. The electromagnetic spectrum is continuous, and that just means that between the gamma rays and the radio waves, the waves are essentially the same properties. However, they have differences in frequencies and wavelengths that tell them apart. And oh, we've done this one, but we're going to do it again because we believe in doing things right. F is equal to 7 times 10 to the 9 hertz. The speed of the wave in velocity is 3 times 10 to the 8 meters per second. And I even think I messed this up a little bit. Sheep daddy is equal to I don't know how many. Velocity is equal to frequency multiplied by wavelength. Oh yeah, that's right. Velocity divided by frequency, because I want to make the wavelength the subject of the equation, so I'm going to write that down. My velocity is 3 times 10 to the 8 divided by 7 times 10 to the 9. That will equal my wavelength. You can do it either way, by the way. Curvy like that, little curvy, straight like that. Nobody cares. I don't care. Maybe the Greeks care, but, you know, don't tell them and we'll be fine. 3 times 10 to the power of 8 divided by, and again, I'm using A over B here, so I press down. 7 times 10 to the power of 9. Velocity divided by frequency. Yes. Giving me my answer of 0.043. 0.042857142. Completely fine to do that, but let's not do that by itself. We're also going to tidy it up because we're kind and considerate people. Oh my God, this just keeps on going. It just doesn't stop. It surely must soon. Oh my word. Okay. I'm going to take another little break so I can curl into the corner and cry.